All right, when I ask kids to balance chemical equations, it's usually a process. Usually kids start off and they don't get it. They're just like, I don't get this. It's a problem. What's going on? And then what happens after a little time, something just clicks. And when it clicks, then all of a sudden they're just like, oh yeah, I get this. This is not a problem. So what I hope to do in this video is I hope to show you a way to visualize balancing equations and make that process click for you a little bit faster. So I chose two examples. One example I chose is making water, and the other example I chose is making hydrogen peroxide. And let me explain why. The reason why is that water has a chemical formula of H2O, and hydrogen peroxide has a chemical formula of H2O2. So they are both made out of the same thing. They are both made out of hydrogen and oxygen. So if I want to put down, this is my product here, hydrogen peroxide, and here's my product on that one, it's water. So my reactants then, what went into those? Well, to make water, I need hydrogen, which is diatomic, and I need oxygen, which is diatomic. And over here for hydrogen peroxide, I need the same thing. I need hydrogen and I need oxygen. Now, when you look at these two, one of them just kind of looks better, and it's this one. Why does this one just look better? If you have a guess, maybe you could raise your hand. Okay, now let's see a picture of what these things look like. Let's see, here's hydrogen peroxide, and I'll just leave that there. And then hydrogen looks like this. Let me shrink that down just a little bit. And then oxygen, oxygen looks like this. And so you see why this one kind of looks better. On the left side of the arrow, we've got 1, 2 hydrogen atoms. And on the right side, we've got 1, 2 hydrogen atoms. And on the left side of the arrow, we've got 1, 2 oxygen atoms. And we've got 1, 2 oxygen atoms. So this is what we call a balanced chemical equation. Okay. Now over here for making water, this is what a water molecule looks like. And it's made with the same things. It's made with hydrogen. Oops. What do I do here? I do this, and then I select that. Okay. So I can shrink that down a little bit. And it's also made with oxygen. Well, you can see the problem right off the bat. The problem is that my hydrogen is okay. I've got 2 on this side and 2 on that side, but I've got 1, 2 oxygens on the left side and only 1 on the right. So what's going on? Did I somehow destroy an oxygen atom? Well, there's a law, and it says it's a law of conservation of mass or matter, and it says in chemical changes, you cannot destroy atoms, and you can't make them either. So something must have happened. If we can't make or destroy atoms, something weird is going on here. Well, what we've got to realize is that we must not have made just one of these water particles. We must have made at least 2. So let me draw another one in here, drop another one in here. So now what I've done is I have solved my oxygen problem. My oxygen problem was that I had 2 on the left side and only 1 on the right side. But now I've got 1, 2 on the right side. So great, I've solved my oxygen problem. But unfortunately, by solving my oxygen problem, I have created a hydrogen problem. Well, that problem is actually pretty easy to solve. If I made 2 water particles, and that's called a coefficient right there. If I made 2 water particles, then I've got 1, 2 oxygens, and now I've got 1, 2, 3, 4 hydrogens. I must not have started with just one of these things. I must have started with at least 2 of those. So let me drop that, another one of those in here. So now I've got, on the left side of the arrow, I've got 1, 2, 3, 4 hydrogens. And so now both sides match each other. So now this side is balanced. And so I would have a coefficient here as well because I have 2 of these H2s. There's 1, there's 2, and then I've got 1 water and a second water. So by comparing these two side by side, hopefully you get the idea of how to balance an equation. What we do is we mess around with these coefficients until the number of atoms on both sides matches.